Okay, so today we are going to start talking about our last and final transformation. Okay, so if you notice here, the title of this packet says dilations. Okay, so our last and final transformation is going to be a dilation. Okay, if you think about when you go to the eye doctors and they dilate your pupils either get bigger or smaller. Okay, so with a dilation, we are going to be changing the size of our shape. Okay, so we're going to be using a lot of the concepts that we talked about in our unit stretching and shrinking. Okay, so during our unit stretching and shrinking, we talked about the mugwumps. And we talked about how to make mugwumps similar to each other or create imposters. Okay, and if you look here, the green one and this purple one, we consider to be the imposters. Now, the reason why we call these guys the imposters was because we either changed the height and not the width, or the width but not the height. Okay, so if I change the height and not the width, it's going to have this stretched out look. And if I change the width but not the height, it's going to make it have this squished look. Okay, whereas if you look at this guy here, we changed both the height and the width by the same amount. Okay, so it's going to make this guy look identical to this guy, just bigger. Okay, so our dilation, because we changed the size, is not going to create congruent shapes like our other three transformations. It is going to create similar figures. So if you think back to the beginning of last year, a similar figure is going to be the same shape meaning our angles don't change. However, they are going to be a different size. Now we can't just go and change the side lengths using any scale factor. Okay, all sides need to use that same scale factor. Okay, so we are going to try to dilate this quadrilateral PQRS with a scale factor of 3. Okay, so when you start any dilation, you need to first start by writing your originals every time. Okay, so the coordinate of P I see is 2, 4. Q is 2, 2. R is 5, 2. And S is 4, 4. Okay, so we're going to apply the scale factor of 3 to each of the X and the Y coordinates in every point. Okay, so P prime is going to be 2 times 3, so 6, and 3 times 4, so 12. Q prime is going to be 3 times 2, so 6, and again 3 times 2, so 6. R prime is going to be 15, so 3 times 5, and then 2 times 3, so 6, and then S prime, 4 times 3 is 12, and again 4 times 3 is 12. Okay, now we're going to go and actually plot these points. So P prime we have is 6, 12. You're going to plot and label. Q prime is 6, 6. So again, plot and label. R prime is 15, 6. Plot, label. And S prime is 12, 12. So plot, label. Okay, so you should notice that this shape looks identical, meaning that these angles, corresponding angles, stayed the same. However, the sides are just bigger. Okay, so if we go and answer question number 1, It says, how are the side lengths of quadrilateral P prime, Q prime, R prime, S prime compared to the original? So if you go to our original, let's count the side lengths of QR. So that would have a length of 3. Now its corresponding side in the image would have a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's look at PQ in the original. We have a side length of 2. So P prime, Q prime would have a length of 1, 2, 3, 4, 5, 6. And then let's look at PS, which has a length of 2. So P prime S prime is going to have a length of 1, 2, 3, 4, 5, 6 as well. Now I haven't taught you yet how to find the side length of a diagonal line. Okay, so let's just use these 3 lines to make our conclusions. Okay, so if you notice, to get from 2 to 6 is times 3. Again, 2 to 6 is times 3. And 3 to 9 is also times 3. Okay, so we're going to state that the lengths in the image, okay, so where we end up, are 3 times the lengths in the original. Okay, then it says, how do the angle measures compare? Well, we just said for it to be the same shape, the angles have to stay the same. Okay, so we should notice that the corresponding, so the angles that end up in the same spot, angles are congruent. Okay, so for example, you should notice that angle Q is a right angle and Q prime is also a right angle. Okay, these two here are going to go back again to our stretching and shrinking unit. Okay, so we have the perimeter, which would be when we add up all the sides, and we have the area, which is going to be that space in between. Okay, so it says, how does the perimeter of the image compare to the perimeter of the original? Well, if we took all of our side lengths and tripled them, and then if we add those side lengths all together, then the perimeter should also be 3 times that of the original. Okay, so we're going to say the perimeter of the image is 3 times the perimeter of the original. Okay, so if you remember from last year, the area is the tricky one. So for example, off to the side here, if I had a square, they had an area of, or I'm sorry, let's do side lengths of 2 by 2. Okay, so the area then would be 4. If I tripled the side lengths, so now they were 6 by 6, this area would be 36, because 6 times 6 is 36. So if I compare the 4 to the 36, 4 times 9 is 36. So if I tripled the side length, the area is 9 times bigger. Okay, so we said that if I was to take something of 2 and triple it, so 2, 4, 6, and both the height and the width, so 2, 4, 6. If I then go to fill in all the space in between, I'm going to be able to make 9 boxes. Because if this is times 3 and this is times 3, then 3 times 3 is going to give me an area that's 9 times bigger. Okay, so I'm going to erase all this just so I have some room to write this down. Okay, so we should notice that the area of the image is 9 times the area of the original. Okay, and hopefully we remember this is because the area is going to change, not just as the same as the scale factor, but by the scale factor times the scale factor, or scale factor squared. Okay, the last one says to write the rule. Okay, so we took our original coordinates, and we took the x and the y, and to get our new coordinates, we went and multiplied them by 3. Okay, so I have 3 times my x coordinate and 3 times my y coordinate. You're going to see on the practice pages something like this. Well, it will say k equals 3. K is simply just your dilation factor. Okay, so that would mean that I could replace these 3's with any dilation factor or any k value. Okay, let's turn the page. Here, they want us to dilate PQRS, but this time with a scale factor of 1/2. Okay, so on the other page, we had a scale factor of 3. So hopefully we remember that if a scale factor is greater than 1, then we are going to make our image bigger. However, if our scale factor is between 0, so greater than 0, but less than 1, okay, so just some sort of fraction, oops, where'd it go? Okay, then our image is going to simply be smaller. So in this case, our image is going to be half the size of the original. Okay, so let's start by plotting, or figuring out the coordinates for P, Q, R, and S. So P is going to be the point -2, 4. Q is going to be the point -4, -4. R is 4, -4. And S looks like it's 6, 2. Okay, so I'm going to apply the scale factor of 1/2 to all of these. Okay, so all you're going to do is you're going to ask yourself, what is 1/2 of -2, 4? So half of -2 is going to be -1. Half of 4 is going to be 2. Okay, so for Q prime, half of -4 is -2. So it'll be -2, -2. R prime would be 2, -2. And S prime is going to be 3, 1. Okay, what you're going to do is you're going to go ahead and plot these, label with your primes. Then you are going to answer questions 1, so tell me about the side lengths. 2, tell me about the angle measures. 3, tell me about the perimeter. 4, tell me about the area. And 6, you're going to write the rule. Okay, after you've completed this page, you're going to have me check it. And then I'm going to tell you to turn to page 6 and 7. And you are going to complete the practice on page 6 and the practice on page 7.